How badly do SSDs degrade without trim? SSDs have been out for a few years, and have seen all kinds of usage patterns. Windows and Linux support the trim command, with Mac OS still trailing behind here. Update 2011, it appears OS X Snow Leopard has support for trim and Apple-branded SSDs. There's a utility that enables trim in non-Apple SSDs. I'm sure plenty of Mac users, in pre-trim version of Linux, have SSDs. So, to you folks, have you noticed a degradation of SSD performance during its lifetime? How long have you been using the SSD, and how bad is the degradation? I'm assuming that even at its most degraded state, a modern SSD would still smoke a traditional hard drive in terms of performance.
I have a AUX Summit SSD in my work laptop running Win 7 x64. I had installed the drive just prior to the firmware update that enabled trim, so I was running for a long time with no trim. I noticed some pretty substantial performance problems after a few months. It became unbearable when, after installing an Apple Bluetooth mouse, the cursor would occasionally pause while compiling a large project within Visual Studio 2010. Also, my compile time for this project was then around 20 seconds, up from 13 seconds when the drive was installed initially, though more classes and projects had been added, so maybe not the best indicator. I backed everything up to my Windows home server, updated the firmware, it clears the disk, which is why I didn't perform the update prior, restored from backup, and performance hasn't been an issue for the past 2 months since I've done this. And back down to around 13 seconds for a full compile for the same project. So in my experience, there is a definite noticeable performance hit over time. This is the reason why I have not yet replaced the HDD in my MacBook Pro with an SSD.
My understanding of this phenomenon is that it affects the longevity of the drive more than it affects the performance, at least from what an end user observes. SSD media can only write to empty file pages, but they can only erase a file block, collection of pages, normally around 128. Without trim, which the OS uses to tell the drive which pages and blocks it can safely erase, the SSD needs to move pages around in order to free up blocks in order to write new data. What this boils down to is the SSD needs to perform multiple physical writes to do one logical write of the data sent by the OS. This is a phenomenon called write amplification. The longevity issue comes into play when you consider that SSDs have a limited number of write/erase cycles per cell, 1,000 to 100,000 per cell depending on the media. This is mitigated somewhat by wear leveling, which is an automatic use of the least used cells on a drive to avoid uneven wear, but write amplification limits how much wear leveling can take place. Wear leveling also leads to some write amplification on its own, due to needing to move data which is not changing under certain scenarios. Since there are still no moving parts in the SSD, it will obviously be much faster than a normal drive even with these issues. However, the relative speed to a non-affected drive could be many times slower depending on how much write amplification is taking place.
There are 2 detailed articles about SSD and trim, for Mac and PC, here and here. To cut a long story short, on Windows you really need trim, or have to do some careful configuration. On Mac, for some reason, it seems to work pretty well without trim. By the way, Jeff blogged about this yesterday.
I have a not-so-joyful experience under Oz here. Being the owner of a MacBook Pro, I bought an AUX Vertex 256 Go drive, and I already saw the write performance drop twice from 80 MB/s to an awful 8 MB/s, twice in a 10 months period. I have confessed that I do abuse it, since this disk contains mainly a huge virtual machine, Win 7 with a disk filled up to 120 GB disk, which I use intensively for compilations every day. My virtual machine is powered by Parallels Desktop. I'm wondering whether my disk is deficient since the drop is huge. However, I do not think so, since I can restore the original performance by reformatting, priming the disk. Maybe the fact that I am running a virtual machine is the cause. However, I read in the comments that some did not have the same drop using VMware Virtual Machine. Notes hoping to help others on how to restore the original performance. As far as I tested, the disk tester recondition method described at this URL was not helpful. You can plug the disk to an external PC after having formatted it and then trim it. It works. You can also boot under Linux from a live CD and use the steps described at this URL. A bit lengthy, but it does work.
If you want to support the channel, please consider subscribing.